Right, hello, my name is Roxanne Guildford. I am a PhD candidate at the University of Edinburgh School of History, Classics, and Archaeology. My specialization focuses around archaeology and also data science and data analytics. My project specifically focused around looking at how archaeologists use data, specifically with archaeologists in connected with the biological sciences. I am also a affiliate of the Center for Data, Culture, and Society and a postgraduate teaching assistant at Edinburgh Futures Institute. I will tell you a little bit about myself first before going into this talk. I have a very broad interdisciplinary background. While a lot of my postgraduate research has focused specifically around zooarchaeology, I also have worked with public heritage or commercial archaeology. Prior to my academic career, um, I worked in a large workplace benefits insurance company where I essentially analyzed business workflows and tested best practices and training for new hires. So with all of that together, I ended up approaching my PhD with quite a bit of different sort of background, where I was really curious about how how zooarchaeologists are using the data that we have now today. Are there best practices in research workflows that we aren't participating in? Are there things that we have seen in research that around best data workflows that maybe don't work, like more creative sort of solutions to just, well, we need to standardize everything. And with that sort of outcome, there were quite a few different considerations that I ended up coming to a conclusion with for any kind of data intensive research, not just with archaeology, but especially within the humanities and within the social sciences and anything that sort of bridges the humanities, social sciences, political sciences, plus like any of the physical sciences or like environmental sciences. So these considerations boil down to essentially three topics. The first one was accessibility, specifically around accessibility of data, accessibility of software, and accessibility of training. The second consideration was standardization. Is standardization really the answer, or should we be focusing more on comparability? The reason why I had found this to be a really interesting topic was because we do have a huge diversity in backgrounds, in education, in knowledge, skills, interests across, all sorts of researchers. So really, does standardization really work? Or should we be more focused on making our research more comparable? And of course, lastly, there was the concept of data literacy. Now, data literacy was being different than digital and computational skills, but this was a topic that I actually did want to touch on today, though I know that the talk really is about software, but I also will be covering a lot of points around the sort of framework of how are we accessing software and what does it mean to enhance collaboration and how are we sort of understanding the data outputs that are coming from the software we use and how can we kind of make better choices around what kinds of software to use for our research. And so real briefly, just wanted to share this quote from Wikipedia, which is that data literacy refers to the ability to understand, interpret, critically evaluate, and effectively communicate data in context to inform decisions and drive action. Now, I want to also point out that this doesn't necessarily mean technological skills. This is much more of a theoretical standpoint in which we basically having data literacy means that we have the ability to understand and evaluate and to be able to analyze data, and also to be able to know the best way to share data, so that it can be reusable, it can be findable, it can be publishable, and it can be reproducible. So this is focused around making basically better data-driven research. Now, with data-driven research, of course, a lot of times people sort of think about more of the physical sciences, though, of course, like we always work with a lot of data-driven research with social sciences and with psychology and medical sciences. We also look for data-driven research with policy making. However, with not all of the social sciences always necessarily connect with this concept of data-driven research, and that a lot of disciplines still sort of fall back on more informal analysis of research outputs, and that there is also sort of a gap in how we understand what data means. Like, how are we reading graphs? How are we drawing conclusions? How are we looking at the data? How are we visualizing the data? And all of that actually, like all of that theoretical sort of foundation also comes together in the sense that to be able to have data literacy, you require specialized training. Like, this isn't something that's just intuitive, but also, like, even though it's not necessarily a technical data literacy isn't necessarily about technological training. You actually do need technological training in order to support data literacy, because, you know, if you were trying to learn how to better share your research, then you need to know how to share the data, and you need to know like the best software to be able to process the data, to analyze your data, to visualize your data. A great example of this is if you have ever tried to make graphs in Excel. It is not a pleasant experience. It is very difficult, and the graphs are generally just like visually, they're not great. They're very limited. So when we're talking about using any kind of software, not just productivity software, but also research software and support services, being able to communicate and share your data, being able to analyze your data appropriately in a more robust way, and being able to make sure that your data is interoperable and it is replicable, then that also means having at least a basic skill set of some different types of research software. And of course, that takes training and knowledge. You can't read your data, you can't understand your data if it's messy, or if like your visualizations aren't up to like research standards. And also, like, quite frankly, you can't disseminate your data if other people can't read it either. Now, one of the things about having these skill sets is that like there's just so much that is available for researchers, and it can be very daunting, and that's why we look at collaborating, because not everybody can have all of the skill sets that you possibly need in order to be able to do good, robust, data-driven research. And especially with subjects that are in the humanities and the arts, some of the social sciences, that sort of training is just not necessarily part of normal like academic process. It's not something that is always taught during school, and even in postgraduate degrees. And if you are a professional coming in from, say, heritage or other industries, and you are working with other academics, whether or not you are trained in you know, in specific types of software or specific types of data analysis, your level of data literacy, all of these are going to be very different depending on your own background. They're going to be higher, perhaps, like depending on the industry that you work in. But in a lot of cases, especially with industries that tend to partner with the humanities subjects, they do tend to be quite a bit lower. And this is a problem because this interferes with being able to accurately reproduce our data. And the reproducibility crisis is something that is just widespread across all of the sciences, but it's especially difficult with social sciences because our researchers are not always able um, to essentially do research with data that can be like completely replicated. Sometimes this is also made more difficult because of like issues with being able to produce primary data. For example, ethical issues around using uh, information gathered from humans, or anything that has to do with privacy or sensitive information. A lot of times, like even if you build in and like a process to be able to like remove all of that and make it the data anonymous even before you're sharing it, it can be very difficult to make that primary data available. In which there are ways that we can kind of work around that, but that is a huge concern as far as being able to publish results. So if you're only publishing the results and the summaries, then people cannot necessarily they can't necessarily reproduce what you're doing, and therefore they can't actually validate like your research process. So being able to choose the right software, being able to connect with a network, and being able to get support like for all of these things is actually really important. Collaboration, like I just have this quick graphic here. The collaboration essentially is the idea that you have research, and bounded by that research, you have your support services, you have your software, and then of course you have your communities and network. And all three of those things are really important in enhancing research and enhancing collaboration because they work together. And if you kind of imagine like the dotted line as the boundary of training and knowledge, they work together within that boundary in the sense that like you do have to have that training and knowledge, but the training and knowledge part of the research can come from the support side. It can come from your network, or it can come from like say your own experience in your own self-learning while working with the software. So one of the things um, about working with data is that researchers in general are effectively data producers, and especially in the humanities, the arts, and the social sciences, we do make a huge amount of digital data, and a lot of it is really complex. It's not as easy to consider like what kind of software support systems that you're going to use for, say, qualitative data. If you have data that is like non-numerical, if you have non-normal data, such as if you're working with different types of media, visual media or sound media, there are so many different things that kind of can really make this kind of research complex. And because of that, like we are now producing so much data from our own research that like researchers in the social sciences really do need to have a better understanding of how to deal with all of that data, to have to how to manage it, how to better collaborate like with other people, because this is not, we can no longer sort of support the idea that like we can just do our research in a bubble or in a vacuum, that because the research is so in-depth and so complex, especially when we're considering human activity, when we're considering ethics, when we're considering you know, our place like in the environment, if we're considering sustainability, all of these things really like just end up creating sort of like a situation where we have a huge amount of data and we don't necessarily know how to manage that. And we also like analyzing it can be very difficult, but also like once we're done analyzing it, there's sort of a lack of understanding and a lack of training around being able to share that data. And then of course, not just sharing it, but we also have a hard time being able to access it and then being able to do our own research based off of that data, because otherwise, you know, if you can't continue the research from other people's data, then there's not a whole lot of a point of actually publishing it. So one of the things that I wanted to touch on today is this concept of SHAPE, which is an acronym. And it means it basically stands for the social sciences, humanities, and arts for people in the economy, or it could be people in the environment. I have also seen environment. Basically, this is similar to like the acronym for STEM, the science, technology, engineering, and maths. But instead of just adding that A into STEM and making it STEAM, there's actually now a sort of different initiative. And one of the things that I really enjoy about the concept of SHAPE is that it is as important as STEM disciplines. And it is really, the idea is that it's not to be separate from STEM, but it's to be collaborative. This also emphasizes the concept that the social sciences, humanities, and arts are and can have data-driven research. And this kind of empirical research, oftentimes contributes quite a lot towards developing like technological innovations or answering complex research questions, designing sustainable policies, anything that basically has to do with working in that humanities and culture aspect of research. Because and also like within the context of developing like that creative and critical thinking process that is so important. So really it's essential to have more robust, reproducible and reusable, I like the 3 R's, robust, reproducible and reusable data. And one way that we can do this is essentially through making better choices with how we are using various software, and which software that we choose that we do decide to use with our research to be able to sort of emphasize shareable outputs. Now, like when I'm talking about shareable outputs, I'm talking about using software in a way that creates data that is essentially around that adheres to like the fair data principles. Now, the fair data principles do focus around a lot around metadata as well, which you can write good metadata for data output for any kind of software, but like there are some file types and data types that just end up working a lot better when it comes to practicing with open science and open research. So if you aren't familiar with the fair data principles, when we're talking about that with the data, we're talking about essentially like having 4 different characteristics of data that make it able to be widely used and to be sustainable. And really the point is to increase understanding to like your audience, whether it's a research community or whether it's a public audience, or if it's like, industry or private sector. It doesn't matter who it is, like all of these principles are really important. So findable means that the data needs to be able to be read by humans and computers. Like a lot of times this has to do with making metadata machine readable, but also like it does have to do with like knowing how to make sure that your data is out in the right kind of repositories, that it's being disseminated correctly. Findable also has to do with being able to find support services, so making sure that your data is in repositories that can be searched, and that even if you have to put an embargo on your data, that in the long term, it is still something that can be found online, and it's not just going to end up in a file folder somewhere with only a physical copy, in a basement, which unfortunately, like in my line of work, tends to happen a lot. Accessible. Now this has to do with making sure that how the data can be accessed in the long term. I also always consider accessibility in a different aspect as well, because when you're talking about making data reusable, you're also kind of considering like, well, what really makes data accessible? If your data is in a format that is more proprietary and that is not reusable to a wide variety of software platforms, or if it's only reusable to software platforms that are licensed and could be prohibitively costly, then is your data actually really accessible? So interoperable and reusable are two, like sort of, those are actually, I think, probably the most important in this talk, specifically because interoperable means, can your data be integrated with other applications? That has to do with like, what is your data file type? Like, how are you storing the data? Again, all of these concepts link together, but if you're storing your data in a file type that is specifically linked to a certain type of software, if that software ends up being, no longer being available, then your data is useless. And again, being an archaeologist, this happens a lot as well. This also has to do with, whether or not your data is being held like in databases that essentially aren't being maintained, or if it's in like a public repository that can essentially be accessed by anybody. So it is like really important to make sure that your data is saved and shared in a form that can be read and processed and analyzed and manipulated and repurposed by as much of a variety of software as possible. And then reusable. I think I've gone over that quite a bit in this specific talk. It is, sort of a big topic for me. Data should be well described. Your methodology should be well described. The version of your software that you use to analyze it should be well described, because this is what makes it able to be replicated and experimented on or added to further studies. If the researchers understand like how you, not just like what your base methodology was, not like how did you quantify this or how did you qualify that, not just, like what your coding syntax was, but if they understand, well, like this is the process, this is the documentation process of how you actually did the analysis based off of this version of this software. Now, if that version is quite outdated to the point where like that coding process is really no longer going to be applicable, then it's much easier to find a workaround to be able to like reproduce your research, or to be able to even just use your data if that is understood. But if there's no information, if there's no good documentation besides what your theoretical methodology was, then essentially like that's not good for the sustainability of your research. Now, I'm going to move into talking more about actual software. now that we've covered quite a bit of more sort of a theoretical aspect, I really want to talk more about like what the main topic of this talk is around. So software, when we're talking about software, when we're talking about sharing, because ultimately if you're collaborating in anything, then of course you have to be able to share your data, and you have to be able to share your processes and your analysis methodology. And that also means that like everybody that you collaborate needs to be able to have access to the same kind of software, even if you don't necessarily have the same sorts of skills. So there are kind of quite a few different concerns around using software and sharing data. Some of those concerns have to do with applying better practices in the social sciences around like data security and ethics, around let's see, like licensing data and software, essentially, as I said before, disseminating primary data, and also documentation practices. So like the three key difficulties, as far as I'm concerned, with essentially collaborating when you're considering collaboration from a software perspective, from like a technological skills and technological accessibility perspective, is that, okay, so first of all, not all software is open. What this essentially means is that there are a couple of very popular software programs that are essentially are considered what is called industry standard, or like essentially like research standard, that are very expensive. They require licensing on an individual basis, or like, if you work for a company, and they don't necessarily, they tend to be a little bit more what we call like black box processing, which is that and when you're using sort of like when you have a user interface where you are doing your analysis based off of essentially selecting menus, then it's a lot harder to produce any kind of record of how you completed your analysis. You can oftentimes record like your keystrokes, or you can record an output that essentially says like, what was the processing output for this. But those are oftentimes not in formats that are very easily understood, unless you are really, 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 really like well skilled already in that software. So one of the things about using these sorts of like standard software, proprietary software, is that they do tend to be a lot more stable. They do have like their own IT support, which is great, because one of the drawbacks of, well, I wouldn't necessarily call it a drawback, but it is a challenge. One of the challenges of using like open source software is that because a lot of like the plugins and such that you are working with tend to be quite experimental, especially the packages, it's not always as stable. And as there tends to be no centralized IT support, you have to rely on the community for help if you have any kind of issues. But unfortunately, again, like these sorts of software products just are really not widely accessible. So for a couple of examples of like what you might run into with this is, for instance, like probably the biggest one in social sciences is the use of SPSS, which is your software analytic, I'm sorry, not software, statistical analytic software, versus like coding your statistics in R or in Python. Another one that does crop up, like even in well, not even, but like in social sciences, of course, humanities a lot, is the use of ArcGIS for geographic information systems versus QGIS. ArcGIS is like a brilliant system. I've worked with it quite a lot. Um, and it makes great graphs. I mean, it does like geoprocessing amazingly, but it is prohibitively expensive. I mean, luckily with ArcGIS, there is a lot less of the black box processing, and you can save your file formats in shareable form so that like you can do processing in other types of geographic information systems. So like in that case, using ArcGIS doesn't necessarily mean that you are making data outputs that are not shareable, but access to that particular software is very limited. Another example of this is like what sort of like productivity software are you using? I have run into situations where I sent a student a spreadsheet in CSV format, and they sent it back to me in a numbers file, which is like the proprietary spreadsheet format for Apple. And I had no way of being able to access it because I don't have the iCloud. So in that case, you know, this is a situation of somebody not understanding that like using numbers, using pages, is not really accessible. And just like if you were to share a spreadsheet necessarily using like the docx file format for Excel, that's less shareable than sharing a spreadsheet in either CSV, or like if you have a workbook and you can't necessarily share your spreadsheet in CSV, you can use like LibreOffice, which is like ODS. So there are other options to be able to use different types of software, either research software, productivity software that makes your data a little bit more accessible to everybody. And while it seems like not so much of a big deal, again, you know, working in heritage, a lot of heritage companies are actually very underfunded. Archaeology companies are underfunded. Freelancers oftentimes don't have the money to be able to afford licenses. So I have even worked as a volunteer for museums, and they all had very, very, very outdated licenses for Microsoft Office, like severely outdated because they cannot afford, and they were all desktop applications, they cannot afford Microsoft Office 365. So, you know, these are public sector organizations that, you know, are working with very outdated productivity software. So anytime that I had to share data with them, like I couldn't use Access database. I couldn't use quite a few different types of software programs with them because they just did not have any way of being able to like really work with that data very well. So I had to essentially like I had to make my data all sort of backwards compatible in order to be able to work with them effectively. So licensing issues with software. One of the things that I will touch on a little bit later as well is that there are software that are quite often used in the social sciences and humanities that are not necessarily supported by the university. Now, there can be some legal issues with using different types of software. Not all software is available in different countries. We actually have one of the software platforms that like the university kind of works with is called Notable, which is something that that is available for teachers, not necessarily students, but like you can't use that outside of the UK. So also, like if you're traveling into different countries, there can also be issues with accessing like non-desktop type software, like software that relies on access to internet, that relies on web-based browsers, that relies on mobile apps and things like that. So those can be quite difficult as far as like if you have to travel or if you are collaborating with other researchers from other countries. And the other thing to note is that um, the licensing for the software and for the data output that is supported, that can be supported by the university. A lot of times that is not going to be supported for anybody else. So if you're not, if you happen to be using analytical software, if you have like a research software program that you got through information services and that you got a license for from the university, that does not translate to anybody else in your working group unless they are student or staff of the university. So, you know, if you were working with data that requires license, like for example, NVivo is a very popular qualitative data software program, but it does require licensing, and you can only get it like renewed yearly here and through the university. So if you're using that as a platform with a group of people that is also not part of the university, you are going to have to pay for that licensing in order to use it collaboratively as a group. So as far as like when you're talking about licensing with data outputs, like that basically means like what is the intellectual property? What is the IP of your data? Now, even if essentially like any data that you collect and any data that you code, you do have intellectual property rights. So there is a certain kind of copyright that is kind of inherent with, like, if you are coding, whether or not you're coding analysis or if you're coding your own software or if you're coding apps, it doesn't matter. But you do actually have to apply that license. And in order to do that, you need to understand like what the licenses mean. So if you do not clearly document like what the licensing for your data outputs is, then it doesn't really make your data, like when you publish your data, whether or not you're keeping it like in a repository, if you're keeping the code, say, in GitHub, or if you're putting it like on data store, it doesn't make it, like, if you don't have clear documentation and uh, as to like what your licensing is, you know, for example, if you want it to be Creative Commons licensing by attribute or whatnot, there are a bunch of different options that you can choose for your licensing. So you can actually choose to close down the licensing on your data to make it so that people cannot actually, you know, or are very restricted from being able to use it. But the way that licensing works is that if you put the parameters of your licensing for your data or for, you know, your software coding or anything like that, you cannot revoke that if the users are essentially using your data within that expectation, within that boundary parameters. And, you know, so you can't just basically say that, oh, well, like, I don't want people to be able to use this data anymore if they've already used it in a way that, like, you know, is in the way that you've already like prescribed. So the other issue with licensing, of course, is if you're working with industry data that cannot be publicly shared, because, you know, the company that you are working with or the government office, the government body that you're working with essentially owns that data. So of course, you know, like if you are collaborating with others, or if you yourself happen to work for anything that is in that sort of situation, which, you know, like I have done quite a bit, essentially working in commercial archaeology, none of the research that I did and none of the data that I produced could be publicly shared. It was highly protected because of the kind of work that it was, and because of the clients that I work for and because of the government protections. So like that's another situation where you have to be very careful about you know, essentially like when you're working with your data, you do need to make sure that you are following the software guidelines for that company, because oftentimes they do have their own licensing or their own like they might be able to give you access to a specific type of software, but then of course remember that like anything that you make might be fully proprietary to them. And so that's just kind of another consideration that can inhibit uh, with wider collaboration. So, okay, so to kind of, actually, sorry, I just realized I almost missed point number 3. Okay, so I talked before about data literacy, but now like I just also wanted to point out like digital literacy and online research, because a lot of times like digital literacy, being able to like safely use data and be able to critically engage with data when it's online in that kind of format. A lot of times, that's overlooked a bit when you're talking about like say software skills. But mostly because like web-based applications and such aren't necessarily considered to be like research software. However, uh, in order to use research software, you need research data. And depending on what your data collection methods are, you might actually be doing online research, especially if you're doing something like a systematic review, where, you're searching for online repositories, you might be searching on the web for journal articles. And this is, the data collection process is an important part of your research lifecycle. And therefore, uh, one of the difficulties that has kind of started coming up a lot with the social sciences and humanities in particular is that there does seem to be sort of a reduction in digital literacy, and that that there is now a need to revitalize research skills, especially when using research of other people's data, like other previously published data, because there's because it's basically become an over reliance on mobile apps or on AI for doing online research. I mean, I can't even use Google to look up an article anymore without Google like tossing me, an AI overview. And so we really need to sort of divest ourselves from that, because that is not going to help as far as basically teaching researchers how to collect the right kind of data. Because if you collect the wrong kind of data, if you're not like sort of critically thinking about like whether or not your data is accurate, it doesn't matter how good your software processing skills are, really, because then you're still working with inaccurate data or completely false data. Okay, so I just kind of wanted to, or I realized that we're getting really close to the end of the talk. And I do want to say that there are a lot of links in the next few pages. And unfortunately, I can't go over like all of the resources in these pages. However, I have compiled a document that will be shared with the links and with more information, because quite frankly, just the resources and the software available that would really benefit social scientists to be, engaging in more collaborative and in more rigorous research. There's just so much. And like, so I do want to just sort of briefly touch on this concept that collaboration essentially means the concept that you are connecting with support staff from an institute, as well as research clusters or research groups that may be within that institute or can be with like in other bodies outside of the institute. So collaboration can go both ways. It can go between your support staff with the university resources, or it can go between your peer groups, other researchers who have interests that you've been able to connect to. But in this case, when I'm talking about research support, I'm talking about university resources, or I'm talking about institute resources. So not necessarily like finding support based off of, say, a research cluster that you've been able to join, but essentially working with an institute itself. Now, one of the things that I would like to point out is that IT support or specialized training is often offered for software that is supported by a university. But again, to reiterate, like they do not, that kind of support is really not offered for external software or for non-students and staff. So for instance, like if you go onto the information services computing software services, you will see a list of all of the software that is supported by the university that you can ask for licenses for, or that you can ask for access to. In many cases, you will actually find like that the university offers training for like other types of software that you do not get through information services. For example, if you want training in Python, or if you want training in R, you know, there are always classes that are available from multiple places in the university. But like those are two programming languages that you know you don't need licenses for, so you can just download themselves. You don't need to have that support from the information services. That also means that if you have trouble with learning or coding in, say, R or Python, you do kind of have to rely on external help for that, and that in itself is its own training process. So I did put academic support librarians here because you would be surprised like how helpful they can be. They don't necessarily provide like software support, but they do have a huge amount of information as far as like how to manage your data. And you can actually I have actually taken some really interesting courses that were geared for support librarians that were essentially like hosted by academic support librarians, including learning how to use certain types of essentially data carpentry software. So it's always good to sort of just acknowledge them. And of course we have like the Edinburgh Research Data Service. We have essentially quite a few institutes that sort of offer different types of training. Information Services has its own digital skills design and training team that you can go through, and you can essentially go through like a training program. You can find like online courses, or you can even kind of get an assessment about like what your sort of digital literacy is like, and where you could benefit more from training. Of course, it would be remiss of me to not mention that the Software Sustainability Institute, of course, also offers training in software programs. Edinburgh Carpentries essentially offers a lot of training around how to do data carpentry, and that doesn't also include software training. The Digital Research Services is more of a sort of if you haven't visited their site, I highly recommend it. I've actually worked with Digital Research Services twice as an intern, and they're amazingly helpful. They are sort of a one-stop, well, the kind of resource as far as learning about your research lifecycle, and specifically learning about the resources that are available from the university. Now, like, to be honest, they are really comprehensive as far as what kind of software resources are available, like sort of highlighting research clusters, things like that. But really the biggest benefit for them is the fact that they have a decision tool that can kind of guide you as far as what kind of services and what kind of software software like kind of training services, but also access to specific types of software or like computing services that are available at different stages of your like research. So I highly recommend going onto their website and taking a look at that. The Center for Data Culture and Society has kind of gone more into supporting like methodological knowledge, but they do a huge amount of training services, especially around data literacy as well as coding. Like you can take a lot of classes through them that they are always posting about. One of the things that I love about the Center for Data Culture and Society is that they really highlight research groups and that you can kind of connect with, but they also tend to offer social events. So like they might offer web seminars, but they also offer like something called ficas, which are like very short sort of online there's online meetings where you can actually get together with other researchers that are connected with like say like the College of Arts, History and Social Sciences. So that's one of those sort of more collaborative like resources as opposed to software resources, and you know of course EFI research as well. So to kind of like go into a much more broad like research network, which I do realize that we're running a bit out of time here. I kind of wanted to point out now these are associated with these networks, and these institutes are associated with the university itself, but they also like connect with the wider sort of community. And of course, like we have Adina, which offers a huge amount of like different types of computing services. The EPCC as well, like that's where you can do like your supercomputing. The Alan Turing Institute provides like a lot of networking opportunities, and they also, I mean, there's a lot of projects that are also supported by the Alan Turing Institute. I have already kind of talked about Shape Innovation is actually a really interesting tool. If you go onto the link again, like links will be provided for you to follow for all of these resources. If you actually go there, that also gives you an option of being able to sort of click through some different research core like concepts, and actually to be able to connect with research clusters and like how you can find them that you know are focused in sort of different subjects that you know are all involved with the sort of overarching shape initiative. So like those are for sort of a more broader network where like you were really sort of looking at being able to connect with people, but also to be able to connect with like computing services. Now with the computing services, like obviously like in the humanities and social sciences and the political sciences, we don't usually use like computer clusters or like high processing computers. So for instance, Archer 2 and Eddy are really underutilized by, you know, the social sciences. So there's always like sort of an emphasis to basically say, you know, like this is these two are something that can actually really be utilized, and that can be there's training that's involved like that you can get, like there's a whole bunch of support you know, so if there's any kind of research where like you can kind of take advantage of those, I absolutely definitely recommend it. Data store, data sync, and data share, these are all services that are offered by the university. Essentially, they allow you to share your data, but also like you can sync your data. So with data sync, you can actually sync data with other researchers who are out with the university, which is like I think quite amazing, because then it helps with that whole collaborative effort. Um, and virtual lab services essentially, you know, creates basically helps you create like a virtual virtual space computationally, so that you can kind of have like a virtual lab that you can work with. And ELM is an AI platform that university supports. I have not actually checked that out too much, but essentially that's like it's supposed to be a much better solution to like using something like ChatGPT. So let's see here. Okay, so again, lots of other links. All of these will be shared. Mantra is really great for finding like self-guided practicals. LinkedIn Learning, if you're a student or staff, you have free access to all of the courses online. There are some, you know, different sort of quick guides and pamphlets like managing sharing data, guide to research data management and such. Fair software is really like interesting. These are all available like through the library services online from the university. And choose an open source license. Choose a license is a really good online resource that you can use as far as trying to make sure that you have the right licensing for your data, especially like if you're coding new software, you need to make sure that gets licensed. And then of course, there's actually a really nice journal article called Good Enough Practices in Scientific Computing that I highly suggest. Like if you're able to actually read through it, then that would be something that, you know, is definitely beneficial. Okay, so just to quickly wrap up here, basically the conclusion just from all of that information is choosing the right software and like how your data is stored and shared. Of course, it's going to aid in collaboration. Basically, it means that everyone who is part of that research group or is part of a research project is able to work sort of at the same level, even if you have vastly different skill sets. If somebody is really quite skilled with analytical software and another researcher is not, there still can be you can still have a good collaboration if you have like a common ground. And that oftentimes just has to do with kind of understanding your data, knowing what the software does, so that you know, the other researcher at least can have an understanding of how the data is being processed. And that basically means making sure that like your software and your methodologies and the way that you store your data and the way that you share your data basically is as open and fair as possible. And networking, of course, connects you with other researchers and skill sets. But this is like, again, really important because not everybody can know everything. And you know, when you are very busy working through your research, sometimes like taking training skill sessions is just not going to be an option. So of course, like, you know, collaborative work means that you're going to get different perspectives and you're also going to get different skill sets. Now, of course, the supporting staff provide the access and training for the university offered software. They also can signpost to network opportunities. So they are a great resource as far as like the specific software that is being supported by the university to be able to find training or to be able to find networks that can help you with collaborating for your better research. And of course, like that means connecting you with associated institutes, which offer the wider community that you need, and also can offer like their own training opportunities. So that is my talk for today. I did actually have one example of a really interesting network that I can share if we have some time, essentially going online, and that would be the New Reel, is which is a collaboration, basically working between the Alan Turing Institute and Edinburgh College of Art, but it essentially takes AI and uh, mixes it with like creative art and also like prototype design to sort of like build like these futuring kind of projects that really are quite interesting, but also sort of like essentially they look at future societal future sustainability issues and sort of engage with them critically, but not just necessarily from a standpoint of just the arts or just AI, but a really interesting blending of the two, plus like technology and social sciences. So I highly suggest taking a look at them if you've got the time, and that's about it. And of course, I would be happy to open for any kind of questions.